A little practice makes perfect. But you still make mistakes from time to time. That wasn't supposed to happen. So let's do it. Let's dive in and get some additional examples of subnetting based on network requirements to solidify this concept. So you've seen multiple examples. You've seen Class C, Class B, Class A. I'm going to step back from Petropolis for a little bit because it would just take too long to create scenarios around every single one. You've seen the 3 steps, and we're going to be referencing it quite a bit. Here are the problems. I've got 3 problems for you, but it's going to take more than 3. I'm just going to do 3 with you, and then I'm going to launch you, and I'll it's just shoot shot a slingshot. There's so much subnetting stuff available online where you can see the problem and then they'll have a verification so you can make sure your answers are there. I'll give you a few of those resources when we're done. But for now, let's do 3 together, all right? All right, so I've got one of each class. So first one says I should read this first. For the problems below, determine the correct subnet mask and at least 3 network ranges, right? And that'll make sure that we can know what that subnet mask means and we have the increment and all those concepts down. So given 200.5.1.0/24 class C, break that into at least 50 subnets. Okay, 200.5.1.0/24, 50 subnets. We can do that. 128, 64, 32. Have you remembered these yet? Can you write them while talking about something else? Like I can. So 50 is our number that we're looking for. And again, we're not so much after the binary number. We're after how many bits does it take. Our first one goes right there, so we know it takes what? 6 bits, right? Good. 6 bits. Now, reserve the bits in the mask. We have Class C, 255, 255, or I'll just write the /24. 21 or 24 bits, right? So let me write those out. There we go. And I just had a thought as I was writing with all my pen flipping wizardry. I totally forgot to mention at the beginning. I want you to don't just watch me do these. Please don't do that. That would be doing yourself a disservice. Go back to where I showed all the problems and try them yourself. I want you to get stuck, really, because that's where you're like, and then you come and watch it and go, oh, that's right. And then that's where it goes deep. It doesn't work. It doesn't stick, I should say, until you actually apply it and try it yourself. Okay. Now, disclaimer done. Back to this. So reserve bits in the mask. Okay, so we want 6 more bits. 1, 2, 3, 4, 5, 6, right? Because we want more network, so we're extending the network bits. These last 2 remain 0. That moves to a /, what would that be? 24 plus 6 more is 30. And our decimal version of our subnet mask, if they wanted that, would be 255.255 dot. And then again, I mentioned this early on. It's a lot easier sometimes, instead of adding all these numbers together, to know that you have 255 and subtract what you don't have, which is 3 in this case. So it's 252. That's our decimal version of our subnet mask. Our increment, our lowest network bit, is a 1, 2, 4, right? So now when we come down to do our network ranges, which I have to do in a different color, is 200.5.1.0. And we use our increment of 4.1.4, .1.8, and we could keep going down and down to, this is the start of every single one of the networks. Start. This goes through 3, through 7, through 11, through, what would that be, 15, right? Because the next one's 16. So you can't use the first one, you can't use the last one. You have 2 usable IP addresses per network. Now, you might look at that and go, why on earth would you do that? Well, believe it or not, you and I just found the second most popular subnet mask in the entire world. What? Yep, Class C is the most popular. This one is the second most popular because it is extremely useful for point-to-point WAN links. That's where you have routers that have a connection to another router. That's a single point-to-point, 2 and only 2 IP addresses. This subnet mask gives you exactly the number of IP addresses, 1 and 2. So for instance, I could say, this one is 200.1 or .5.1.0/30, right? This is the .1, that's the .2, that's the network, and that's all the network that there needs to be. Now you might be thinking, do I need to have a network for that between routers? Yeah, you do. Every interface of a router is a network. So I'd say it all over again. Every interface of a router is a network. So when you have a WAN link, a serial port, or an Ethernet connection that goes to one other specific destination, that's a point-to-point WAN link. You need a subnet for that. So that fits this directly. The other thing worth mentioning is, notice in this example, I stepped away from private IP addressing, right? In all the previous examples, I've used things like 192.168 and 10 and 172.16, all private addresses, which are typically used inside of a network. Internet carriers, internet service providers have to do subnetting all day long. And I know it's kind of a tangent. It's not really a tangent. It is so good. Hang on. Let me just break out of my slides for just a second. The internet, right? You know at this point that the internet is just a whole bunch of networks connected together. And those networks are managed by internet service providers, right? ISP. So this, we'll just say this is ISP1. Maybe it's Sprint, and this is Cox Communication. This is ISP2, and over here is maybe AT&T, and all these giant ISPs. And how do they manage their IP addresses? Well, in the United States, there is ARIN. If you go to ARIN.net, it's actually government run. ARIN.net, I think it's .net, it might be .gov, but ARIN, just Google ARIN and you'll find it. The American Registry for Internet Numbers. So these guys, back when there was public IP addresses still available, by the way, IPv4, if you didn't know, is gone. We've exhausted the entire IP pool, right? These guys, AT&T, ISP1, let's just say they were Sprint, right? They went to ARIN and they said, I will pay a whole lot of money for, let's just say, let's go with a class B, like 150.1.0.0/16, right? I will pay a whole bunch of money and I will now own that block of IP addresses. Well, what they do then is they subnet. So they have all their customers, customer 1 right here. Yay, with the growth on his neck. Customer 2, all these different customers that are bringing up all of their own networks that, they need IP addresses for. And what does that carrier do? Do they ever hand that out? No. They subnet that thing to no end, down to, you will have those, the reason I thought about that is you'll have the /30 blocks that are your connection to the ISP, and you'll have just that one usable IP address on your side. And if you want more than that, you will pay the ISP and they will do subnetting and break off another little chunk of that and hand it over to you. I just wanted you to see and understand that concept before we went on. Not directly related to subnetting, but so very much so directly related. So number 2, class B example, 150.5.0.0/16. Break it into at least 90 subnets. That's going to be a fun one. Let's try it. So clear this off. 150.5.0.0/16, and we want 90 networks, right? 90 subnets. So same thing, write up our binary chart. And we say, how many bits does it take to get the number 90? Well, that one's really easy because our first one goes right there. Shoop, so it takes 7 bits. 7 bits to get the number 90. Now we're in the class B world now with our subnet mask looking like this. And based on our requirements of 7 bits to get the number 90, we will extend that binary by 7 bits. 1, 2, 3, 4, 5, 6, 7. The last one can remain 0. And all the rest of those can remain 0. So our new subnet mask in CIDR notation is a /23. Again, CIDR, if you haven't heard that before, you should have, because I said it in a previous nugget. Classless interdomain routing. Or decimal notation, 255.255. What would that be? 254.0, right? Our increment is our lowest network bit converted back to, it's not 4, it's 2. Back to a decimal number, right? 2 in that second octet. So we'll go 150.5.0.0. That's where we start. 150.5.2.0.4.0.6.0. And that should give us our 3 network ranges we're needing. End range goes to 150.5. Last IP before 2. 1.255. Careful. Always put that 255 there because otherwise you'll lop off a whole chunk of addresses. 150.5.3.255. This goes through 5.255 and down and down and down, down we would go, right? Cool. That's it. That's a class B example. Let's hit the class A. Given we're back in the private networks, 10.0.0.0/8, break it into 10 subnets. I know you're probably like, that's easy after all it is. Well, yeah, it's just you're dealing with such big numbers. I just wanted to see a big number one, I guess. So let's look back at this right there. 10.0.0.0/8. We're breaking it into 10 networks, right? Number 10 converted to a binary number. Our 1 goes right there. So I know it takes 4 bits to get the number 10. And we've got our /8, so it's going to be 8 ones and a whole bunch of zeros. And by the way, when you start to get used to how these are working, you don't have to write out all the zeros. You just need to do it to where you can see enough of it that you can figure out the subnet mask, right? We know we need 4 bits, and we know that we're after more networks. So 1, 2, 3, 4, 1, 2, 3, 4. The rest can remain 0. We move to a /12 or 255 dot. What'd that be? 128, 64, 32 would be 240. That's 0. And you'll get used to adding those numbers together real quick. Increment is a 16, right? 128, 64, 32, 16. So we go here. 10.0.0.0 is where we begin. 10.16.0.0. These are big networks. 10.32.0.0, right? 10. Well, we can stop right there. That's our 3 networks that we needed. Fill in the end range. We'd have 10.0. Actually not 0. 10.15.255.255. My goodness, that's going to be huge. 10.31.255.255. Are you following this? This one goes up through 10.47. Right? And then down and down and down we go. That's the start and end at each one of those networks. I'm just purely curious. How many hosts does that give us? We have 8, 16, 17, 18, 19, 20 zeros. Flip up my calculator, put it in scientific mode, and let's do 2 to the power of 20. Dope! We'll have networks of 1,048,576 hosts minus 2 each one. Obviously, something that we would want to subnet down further because those networks are just flat out too big. I hope you are feeling really good at this point about it. But again, just watching and doing 3 examples here, there, not going to do it. I would seriously do at least, I don't know you, in the sense of how fast you're going to be absorbing this. I would say minimum 6 more of those. Class A, B, C, 6 more examples, mixing them up. Best case, I would do 10, right? Before you're like, okay, I've got this, and it's really stuck. Then move on to the next skill, and we will do the subnetting based on the number of hosts. For now, I hope this has been informative for you, and I'd like to thank you for viewing.